So in this next series of lectures, we're going to continue to talk about functions, but we're going to focus on some specific attributes of functions that give us important information about them. For example, one thing that's important to know is where is a function increasing versus where is it decreasing. If you think about practical applications, for example, this would tell us where revenue is increasing versus decreasing. It can tell us where a machine is heating up versus cooling down. And we're going to do this by looking at graphs, right? And by looking at this picture, identify where these increasing versus decreasing intervals are. Now, you can do this by looking at the formula for a function, but that's a little more complicated and requires some tools from calculus. So we're going to put that off until a class or two down the road. And for now, focus on looking at what's going on with a picture like this one here. All right, this is the graph of the height of an object that's been thrown up in the air versus the time that it's in the air. So at time t equals 0, it's on the ground. It's tossed up in the air. At some point here, it reaches its maximum. Then it turns around, comes back down, and reaches the ground again after 4 seconds. So our question here is, where is this function increasing? And by increasing, we mean, again, kind of trying to tie this to a physical example, we mean where is the object going up versus where is the object going down, right? And if you kind of think about this almost like a roller coaster, right? Starting at t equals 0, it goes up and up and up, and then it maxes out here right about t equals 2 seconds, let's say. Didn't specify units, but let's say 2 seconds into its trip. So I would say that this function is increasing on the interval from 0 to 2. And you notice I put an open parentheses at 2, right? 2 right here. This is the instant in time when it turns around and starts going back down, right? At that specific point, the function is neither increasing nor decreasing, right? So we're never going to include that specific value, that specific x value, in either of these intervals. Right now, on the other side, what happens when it crosses this point? Well, when it crosses t equals 2, it starts going down, right? So it's on this interval that the function is decreasing. So I would say it's decreasing from t equals 2, and again, parentheses there, right, to 4. Right? So that's how we make, right, this determination just by looking at a picture. All right, now I've got the fancy formal definition here, if you like this kind of thing, right? A function is increasing on an interval if for every number, for every pair of numbers, x and y, in that interval, where x is less than y, f of x is less than f of y. Okay, so for example, if I pick two numbers, right, I'm going to pick this one and this one. You notice x is less than y. And if you look at their functional values, right, this is f of y and this is f of x. Yes, f of x is less than y. And if you pick any pair of numbers over there to the left of 2, right, you're going to get this result. Decreasing is just the other way around, right? If x is less than y, then f of x is greater than f of y. So very technical definition. I put it in mostly for completeness, right? That's kind of a more advanced concept, not something you're really going to have to worry about here. But I do want to talk about this graph over here, right? I want to talk about that same question. I want to talk about increasing versus decreasing. For this thing, you notice the difference here is that this graph doesn't bottom out at the x-axis. It keeps going down here and down here. All right, so what can we say about this graph? Well, it starts off over here and it increases, and it comes up to that same maximum value. So I'm going to say that this function is increasing on the interval from negative infinity, right? Because it keeps going off to the left further and further out. So I'm going to say it's increasing from negative infinity up to, whoops, sorry, open parentheses there, right? Because we're not going to include 2. And then it decreases over here on the other side. So I'm going to say it's decreasing from positive 2 up to plus infinity. Same idea, right? Same things that we're looking for. It's just that this function, its domain, right? If we're thinking in terms of domain, its domain is all real numbers, right? So it keeps going indefinitely, both to the left and to the right. All right, so I've got one more example here. This is actually a very practical example. If you have a mixture of alcohol and water, and you want to separate out the alcohol, what you do is you set up something called a distillation apparatus. You've got your beaker here full of the mixture, and you've got a flame under it. And when you light that flame, the temperature starts to go up, right? So that's what we see here. The temperature is increasing, and there's going to come a point where the temperature stops increasing, and you see it start to boil. Right, at that point, all of the energy being absorbed from that flame is going into turning the alcohol, which has the lower boiling point, turning that alcohol into alcohol vapor. Then you set up tubing here, right, and the vapor goes up into the tubing, and the tubing is not being heated, and it's metal, so the vapor cools down. As it goes through the tube, it condenses, and it drips out over here into another beaker that you're using to collect the results. So you're going to see that temperature stabilize, right? And then there's going to come a point here where it starts to go up again, right? At that point, all of the alcohol is evaporated off, and all that's left in there is water, maybe trace amounts of alcohol, right? And this is the point where the water is starting to heat up, and that's going to continue until it gets to the boiling point of water, at which point our graph stops. But if we continue the graph, it will level off again as all of the energy being absorbed from the flame went to convert the water into water vapor or steam. All right, so I want to ask the same question here. Where is this function increasing versus decreasing? And you see, hopefully you can see, right, it's increasing here, that interval ends at 2, and then it levels off. When it gets over here to 4, at this point it starts increasing again, and that continues here until it gets to 6. All right, so what would I say here? I would say this function is increasing from 0 to 2, and then again from 4 to 6, and that's incomplete, right? Mathematicians, we don't like this kind of thing. We don't like having this interval here from 2 to 4 that is somehow unclassified, right? What's going on in here? Well, we do have a name for this, right? I would say that the function is constant on that middle interval from 2 to 4. All right, so that's increasing versus decreasing. And one thing I want to highlight about this is that whenever we're trying to tell someone where a function is increasing versus decreasing, we always describe this in terms of ranges or intervals of x values. Right, so it's always, and you notice if you go back and look at what I talked about in the examples again, I was always focused on breaking out sections of the x-axis and using them to come up with my final answer. All right, so in the next lecture, we're going to look at another important attribute of functions, that actually kind of ties back to this idea of increasing versus decreasing. We're going to look at, based on a graph, figuring out where a function is at its maximum or its minimum value.